Hello everyone, this is Fadi Abuamara from Shenandoah University in USA. Today I'm going to present our research work enhancing e-commerce security, a novel approach to credit card fraud detection. These are the list of topics to be presented today. First, I'm going to discuss the challenges of credit card fraud detection, then overview of related work, then our proposed methodology, then data description and pre-processing, then the core machine learning algorithms, then the proposed integrated approach. Then I'll discuss the experimental setup and performance metrics. After that, experimental results, system implementation and features, and finally, conclusion and future work. Let's start with an introduction, the challenge of credit card fraud detection. The first point, we speak about the widespread risk in the e-commerce. As we know, credit card fraud is a significant and ongoing threat to both businesses and their clients, especially when we speak about online transactions. Why? Credit card fraud cause direct financial losses for companies and impact consumer trust and security. So the second point, we speak about combating security breaches. Organizations implement different administrative and technical controls to protect data and the transactions. These measures include policies, encryption, and the fraud detection systems to safeguard the online activities. Next, we speak about there is a necessity of detection systems. The increasing use of online transactions highlight the critical need for a robust fraud detection system. Why? As e-commerce expand, so does the potential for fraud. And finally, what's our contribution? We proposed a novel credit card fraud detection system that integrate k-nearest neighbors and naive Bayes. This system aimed to improve the e-commerce security by identifying suspicious transactions in the real time. Let's now explore an overview of related work. First, the evolution of fraud detection methods. The early methods that were used for credit card fraud detection relied on rule-based systems and statistical analysis for detection. Now, these traditional approaches struggle with evolving fraud patterns and could generate false positives. False positive indicating there is a suspicious activity. Once you investigate, it's not. So now there is a shift to machine learning. So the recent research adopt machine learning algorithms. Why? For better fraud detection. Machine learning over the advantage of learning complex and non-obvious patterns from large data sets. What are the common machine learning applications? There are different algorithms like support vector machine, decision trees, and neural networks have been widely explored. Each algorithm brings different capabilities to handle data imbalance and complex fraud behavior. So how we can overcome the individual algorithm weaknesses by integrating complementary strengths. This integration now creates more robust and adaptable detection system for diverse fraud scenarios. This is what we will see that in our research work, we integrated two different machine learning algorithms. So let me now explore the different methodology. First, integrated machine learning model. As you see, we proposed a novel system that combine both the k-nearest neighbor and the naive Bayes algorithms. This hybrid approach now leverage the strength of both algorithms why, which result in enhanced fraud detection. So we speak about data-driven system. The proposed model is trained and tested on a real-world dataset of e-commerce transactions. Why? This ensures the system learn from actual transaction patterns to accurately identify anomalies. Now, the system is designed to notify administrators promptly of any suspicious transaction. Why? This allows for timely human intervention to immediately address any identified fraudulent transaction. And finally, we speak about e-commerce security focus. The system core goal is to improve the security for online transactions and safeguard users, which mean it directly address the unique challenges of detecting fraud within the dynamic e-commerce environments. So let me now discuss the data description and pre-processing. First, dataset utilization. We utilized a dataset consists of 188 e-commerce transactions. This served like the foundational data for training and later testing the proposed model. Next, we speak about feature selection. Key transaction features were carefully chosen as input to the machine learning models, like transaction amount, time, location, and the previous transaction history. Next, we performed data cleaning. Now, the dataset go through cleaning processes to address any missing values or inconsistencies. Give me example. In some transactions, for example, the location or the amount are missing. So sometimes we remove the whole transactions, or sometimes we replace that value with the mean or the median. And finally, we speak about normalization and scaling. Now, features were normalized, and when we say normalized, normalized to the range from 0 to 1. Why? To ensure consistent contribution across all organizations. Give me example. Let's say, for example, the transaction amount usually range from $1 to 10,000. Another feature, like number of items purchased, usually let's say from 1 to 20. Now, without normalization, and assume we are using KNN, the K nearest neighbor. Now, if we have $100 change in the transaction amount, this is just very normal change. It will be considered far more significant than, let's say, change 5 in the number of items purchased. So to avoid these issues, we normalized all features, all values to the scale between 0 and 1. Let's now discuss the core machine learning algorithms. First, we used k-nearest neighbors. This is a non-parametric instance-based learning algorithm that classify new points based on their neighbors. Basically, it assigns a class based on the majority vote of the k closest data points in the feature space. Let me just give you an example to understand. Let's imagine, for example, the credit card fraud detection system has been trained on a data set where past transactions are plotted based on features like transaction amount, location deviation from usual, and time of the day. Now, assume we have a new transaction, a large purchase made at 3 a.m. from unusual foreign IP address. Now, the KNN algorithm identify, let's say we choose K5, 5 closest historical transactions to this new transaction. Now, if the majority, let's say 4 out of 5 closest neighbors were previously identified as suspicious. Now we identify this new transaction as suspicious. Then we have naive Bayes. This is probabilistic classifier that apply Bayes' theorem with a strong assumption of feature independence. Despite its simplicity, it is highly effective for classification tasks due to its probabilistic nature. So what we did now, we integrated both Y, the KNN excel at capturing local data patterns. On the other side, naive Bayes is efficient for probabilistic reasoning. So integrating them allow the proposed model to benefit from both detailed local analysis and broad probabilistic understanding. Let me now explore the proposed model. First, the hybrid integration. Our system integrates KNN and naive Bayes in a mutually enhancing and combined manner. What this means? The integration method leverage the individual strength of each algorithm to compensate for their respective weaknesses, which mean this should enhance the accuracy. This unique combination is designed to significantly boost the overall accuracy of the fraud detection. How? It aims to improve the prediction rate either by cross-validating or feeding one algorithm output to be input to the other algorithm. We speak about optimized error rates. The model now strives to minimize both false positive, which mean legitimate transactions are flagged as fraud, and also reduce false negative, which mean actual fraud transactions are missed. What this means? We speak about increased robustness. This integration approach make the system more resilient and adaptable to diverse and evolving fraud patterns. It enables the model to perform reliably even against new and sophisticated fraudulent transactions. Let me now discuss the experimental setup and performance metrics. First, the dataset itself is split. The dataset consists of 188 transactions. We divided this into training and testing. Why? This allows the proposed model to learn from one portion of the data and to be evaluated on the unseen portion of that data. Now, we assessed the system performance using accuracy, sensitivity, and specificity. Let me go over each one. Accuracy measures the overall correctness of the model prediction. It indicates the proportion of the total correct classifications out of all predictions. Then we have sensitivity or recall. This measures the system ability to correctly identify actual fraudulent transactions. Why this is important? To minimize missed fraud and ensuring effective detection of malicious activities. Finally, we have specificity. This one measures the system ability to correctly identify legitimate transactions as non-fraudulent. Now, if we get a high rate, this means it reduces false alarms, it prevents disruptions to legitimate customer transaction and operations. So for the experimental results, first, the proposed integration system achieved an accuracy of 94.3%. This indicates a high rate of correct classifications for both fraudulent and legitimate transactions. Also, the model demonstrated 94.4% sensitivity. This highlights the system ability to detect nearly all actual fraudulent transactions. Also, the system achieved 94.1 specificity. This means that legitimate transactions are rarely flagged incorrectly. This ensures smooth e-commerce operations. So, in summary, the combined model significantly outperformed the individual KNN and naive Bayes algorithms. Now for the system implementation and features, the proposed system is proposed as a functional application for e-commerce security environments. It can be integrated into existing online retail platforms to monitor transactions in the real time. Also, the system constantly examines incoming online transactions for any suspicious patterns. Also, administrators are immediately notified when a suspicious transaction is detected. And finally, the system can run in the background of a live e-commerce platform. Now, for conclusion and the future work, this research project successfully demonstrated a novel and effective credit card fraud detection system. The system achieved high accuracy, sensitivity, and specificity, confirming its reliability. The system helped educate employees by providing concrete examples of suspicious activities. And finally, as a future work, we need to test on larger and more diverse data sets and also exploring deep learning techniques. Thanks for your attention, for your time. If you have any questions, I'll be happy to answer them.